All right, so in example 5, we are going to graph a function, and you notice there are two different functions here, and the changeover is at the value of x equals -2. So, as always, I will highlight 2 because that's where I'm going to change over. The left side is 2x plus 8. And the right side, we haven't really done one of these yet. The right side is x squared. So we're going to start with the left side, and then we'll talk more about the right side. So the left side, I need to find out what that boundary point is. So I'm going to plug in -2. So I've got 2 times -2 plus 8. That's going to be -4 plus 8, which is going to be 4. And then since I have x is less than 2 for this side, I know that this is going to be an open circle at 4. I'm going to 4 on the boundary line, open circle at 4. Now I want to use the slope of 2 in order to continue this line. So I can't go to the right, so I'm going to go down 2 and left 1 because that would be -2 over -1. Use the -2 slope, connecting to 4, and here we go. That is 2x plus 8. If I were to continue to the right and went up 2 over 1, I would hit that 8. I just am not going to put that in there because it's on the side that's x squared. So when I have x squared, I'm really just trying to fill in a table almost. I usually just start with this value and go over to the right. So if I look at this, this is the value of -2 for x. -2 squared is 4. So that actually ends up filling in this circle because that point is the same. So then my next one is -1. -1 squared is 1. There's another point. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. And 4 squared would be off the paper. So what this actually does, anytime I have a quadratic, I just kind of do it like that and plug in the values. So now I can see I have a linear, and then it connects right away into a parabola. So that's all graphed. The domain of this function goes left all the way with this arrow to the left, and right all the way with this arrow going to the right. So the domain is -infinity to infinity. And then the range, my y values, this one's going down all the way, this one's going up all the way. So my range is also -infinity to infinity. Now this is actually our first continuous graph. If I trace it left to right, because these have that same value at this changeover from one function to the next, that makes it continuous because I never have to pick up my pencil. And now I'm going to evaluate. So f of -4. -4 is going to fall into this category because it's less than -2. So if I'm plugging in -4, I would do 2 times -4, which is -8 plus 8. That's going to be 0. If I look over at the graph, here's -4. That makes sense. F of -2. Now this one, I would plug into this x squared because this is when x is greater than or equal to -2. So if I do -2 squared, I get 4. If I check that on the graph, -2, it's equal to 4. And the last one is 3. That's greater than -2. So I would also do 3 squared, and that gives me 9. So f of 3. So it's important that you recognize which part of the function to plug in your value so that you know how to evaluate it.